Hello friend, this is our next lecture for unit number 2, that is the maximum shear stress theory. In the previous lecture we have learned about the maximum principal stress theory. Now we are going to see about the maximum shear stress theory. Now let's see it. Now maximum shear stress theory. Before that I will use a highlighter here. So maximum shear stress theory. This is how we have seen the example in the previous slide also, in the previous video lecture also we have seen that this is the stress strain curve. Here is the hook limits, here is the elastic limit, and here we have got the sigma y, that is the upper yield point. Here the yield point is started, the lower yield point, after this the fracture will be done. So this is the limit actually, okay, yielding, and this fracture has been done here. So now let's see what this theory. The theories of failure, that is the macroscopic yielding mechanism in ductile material, is understood to be due to relative sliding of material atoms within their lattice structure. This sliding is called shear stress. As you know that shearing is what? If you rub a hand of if you close your hand together, okay, your palm, and if you try to slide it, that is nothing but your shearing part. So this shearing happens here in the lattice structure. Now maximum shear stress theory. Here also the terms which we have seen in the maximum principal stress theory is same in the maximum shear stress theory. But here one thing is that here the maximum shear stress is considered in a biaxial stress system, and in maximum principal stress system maximum principal stress was considered. So here the failure or yielding occurs at a point in a member when the maximum shear stress in a biaxial stress system reaches a value which is equal to the shear stress at yield point in a simple tensile test. Okay, the shear stress which was there in the simple tensile stress and the shear stress which we get in a biaxial stress system, if both are equal, definitely the component will get failure. Okay, so this was the main theory of maximum shear stress theory, and we called that as the gusset or Tresca theory also. Mathematically, or you can say the formally for this theory is, that is the maximum shear stress equal to shear yield stress upon factor of safety. Okay, the mathematical formula for the maximum shear stress theory is what? Tau max equal to the shear stress at yield point upon the factor of safety, which was shown. I am highlighting this part. Now, since the shear stress at yield point in a simple tensile stress is equal to 1/2 the yield stress in the tension, therefore this equation 1 we can write it out as tau max equal to sigma yt upon 2 times the factor of safety. The sigma yt which I have already seen in the previous slide, okay, in the shear stress curve. Let's see some important features about this theory, that at yielding in a uniaxial test, the principal stresses are what? The sigma 1 is equal to what? The yield stress, and sigma 2 we have not considered here, that is 0. Sigma 3 is also 0. So what we will get for the shear strain? That sigma 1 minus sigma 2, or you can see sigma 3 also. And the value for this is 0. So sigma 1 minus 0 is what? Sigma 1. Whole thing divided by 2. That means sigma 1 by 2. So therefore it is written here, that is the shear stress at yielding equal to Sy by 2. That now this theory is mostly used for designing members of ductile materials only. It is not used for brittle material, because in previous theory we have already seen that the brittle materials works for what? On principal stress theory, and ductile material mostly works on shear stress theory. Now MSST means what? Maximum shear stress theory, and MPST means what? Maximum principal stress theory. So MPST means what? Maximum principal stress theory. It will give same result for ductile material under uniaxial stress of stress and biaxial stress when principal stress are like in nature. So MSST is not suitable under hydrostatic stress condition. So this theory is suitable for ductile material and gives most safety. So I think you have all understand this part. So if you have any query, then just contact me. Okay. Thank you.